Is it on now?
Yes.
Okay. Good morning. I am here to talk about building a resilient API landscape and how Azure API Management can help with that. So first of all, my name is Kerkhove. I work on Azure API Management, so obviously I am biased. I work on the gateway itself. If you have any questions, you can reach out. If you have issues with the service, open a support ticket, please. I'm also a maintainer of Kubernetes event-driven autoscaling, a CNCF graduated project, and I am from Belgium. So we're going to talk about a couple of things today. First is we'll look at what an API management service is, very high level. We'll look at how you can improve your infrastructure, your applications. Then we're going to be a chaos monkey, which is basically what I do for a living, and then some questions for you to talk about. So every good thing starts with a disclaimer. We have two types of SKUs, SKU v1, SKU v2, which went GA a couple of weeks ago. I will primarily focus on v1. Sometimes I'll point out some things for SKU v2, but keep that in the back of your head. So, who has seen this slide before? Okay. So we talk a lot about the digitalization of companies and how APIs are the crucial part in that digitalization experience. Because without them, you cannot automate things, expose your data, etc. There's one problem in this chart, though. This is your single point of failure. If it doesn't work, or your digitalization is gone, and you're basically disconnected from all your partners, apps, and whatever. So this is very important, and this is where the resiliency part comes in, which basically means if something happens, what will happen, how will you react, and how will you recover and or mitigate from this. So this is something that usually comes up with customers after they noticed they didn't have it. So this is why I'm here, to help you think about it up front. Sometimes it's very simple, sometimes you need to make some design decisions. Now, if we look at API management, this is a nice marketing slide, but we integrate with a variety of services. We can expose a ton of your backends, but we have three main components. So at the top, we have the developer portal. That's basically a way for you to expose your APIs to your customers or teams internally, app builders, whatever, which gives them the documentation. They can have accounts, subscriptions, they can even try the APIs. In order to do that, you use the management plane, which is through ARM, where you basically define who's allowed access, which APIs do you have, how do you want to expose them, etc. And then we have the gateway, which is what I work on, which I typically call the heart of the service, because if that does not work, that's when they start calling us. This is of uttermost importance to us, that this one stays working regardless of the rest. If you cannot change your APIs, it is annoying, but you will not lose money. If the gateway is down, you're going to lose money. So we're also primarily going to focus on that one today. So how can you design for failure in your infrastructure for API management? So if you come back here, what this slide basically means is this single point of failure is the gateway in API management. If that one is down, you're going down. Like I mentioned, if Dev Portal is down, your partners will complain, but you will not lose any money. Well, maybe because of the partners, but indirectly. So this is where we need to go to Azure 101 first. What is Azure? Geographies. So in one geography, Azure will at least have one or more Azure regions, which is also the data boundary for that geography. And at least one region will have availability zones. There's also pairing. I believe pairing is not that important anymore. It's primarily about the next piece, which is in one region, there's going to be multiple facilities, multiple data centers, which are very close to each other. The new regions are striving to have availability zones in them. Hopefully 3, sometimes 2 are available based on capacity. But this is the important point, availability zones. If you can enable availability zones, always enable availability zones. Because if you spread your compute across the availability zones, that basically means if one physical facility has an outage, the other 2 availability zones will still be up and they work independently. So that's step 1. This also applies to VMs or any other Azure service. If you can use availability zones, always do it. So now coming back to API management, under the hood, we're just running compute for you. So if you create an API management service with 1 unit, what you actually get today is you get 2 machines that run both the control plane, gateway, and developer portal on each of these. There's an asterisk if you're using developer SKU. Who is using developer SKU? Not that many. Interesting. Who's using it? That's my next question. Who's using it in production? Nobody here. Thank you very much. There's a lot of people that do it. When I'm on call, it's always people running dev SKUs in production. So in dev SKU, you only get 1 machine, because that's also why you don't get an SLA. If we do an update, we're basically tearing down the machine, spinning up a new one. We cannot guarantee an SLA. Here we do. We add new machines, get rid of the old machines, etc. There is a DNS name for every service, obviously. And that's it. There's just 2 machines. We run everything on the same machine. And this is the first difference with SKU v2. SKU v2 has a multi-tenant control plane, meaning the control plane dev portal is also multi-tenant. Everything's multi-tenant except for the gateway. So if you spin up a SKU v2 service, you'll get a dedicated machine for the gateway, and the rest is basically shared with customers. This is only basic and standard SKU. We're working on premium. I honestly do not know what the model will be there, so stay tuned for that. So this is just 1 unit. Now, another feature we have is multi-region. I don't know where my map went, but there used to be this nice map. Okay, it's just a projector. So imagine here you should see America, here you should see Europe. So if I create one in Europe, you can add a secondary location in the same API management instance, which basically means you will take one of these units and deploy the same thing in the US so that you have lower latency. We're also sharing state across them so that, for example, I believe it's for not rate limit, but quotas, that is being shared. Why am I saying this? Well, imagine I have my West Europe unit or multiple, and I add another one. There is a difference. You only get the gateway, which has pros and cons. So imagine West Europe goes down. You still use the control plane and the dev portal. So that is something to keep in mind. The primary reason we have this, though, is gateway latency and bringing them closer to your customers and the resiliency. So by doing this, at least, your gateway does not go down if we have a regional outage. So coming back to the host name, you get this nice host name, which actually is using Traffic Manager under the hood. Even if you use 1 unit, 1 region, there's always a Traffic Manager. And we have these regional DNS names for every regional deployment, which you can all access. So we have Traffic Manager out of the box, but if you decide that you want to help Probe itself use your own use your own Traffic Manager because you want to use a different policy, you can, by all means, do so. There is also a health endpoint that you can probe. So please do so if that helps you. So that is on the compute side. What I did not mention is we also support availability zones, which I'll show later. So please, if you can, enable it. Now, I hope at least you do not go straight to production. You hopefully have a production and a non-production or dev test production or whatever approach your company has. And then you have a couple of options. The first one is centralized API management, which means you create one API management instance. Dev, test, and prod is on that same API management instance, but you split the APIs on the service. That is something I would not do, because if a developer messes up and by accident changes a production API, then you will have a big issue. Also, if that service goes down, everything is down. So you can do it. I would personally not do it. Before I joined, I always used the second approach, which is the siloed API management. You create a service per environment, and then you basically treat them as separate environments on an Azure level as well. So if you do your rollouts, hopefully through automation, you can just reuse the same steps, and you have a guarantee that the end result will be the same. This is also why we have premium SKU and dev SKU. Dev SKU is almost identical to premium without SLA, with more limitations, but you can try these features in dev SKU at a lower cost. Yes?
Do you mind if I ask the audience how many use the siloed API management approach? Like, show of hands, how many of you use the siloed in your environment, your customer environment, whatever? Like,
not with API management, but in general.
Okay. Sorry for jumping in.
Nah, no worries. So this brings us to the next approach, which is the federated API management. So who heard about workspaces in API management? 3 people, 4 people, okay. We need to do some better work. So workspaces is basically a way to isolate your configuration. So your API specs, products, policies, everything basically. The missing point though is it all still runs on the same gateway. So if team 1 messes something up, they could potentially influence another team. If you want to have one API management instance, there's no isolation between environments. So something that is coming is runtime isolation. So what you will be able to do is take your workspace and basically get dedicated compute just for your workspace, only exposing those APIs, allowing you to split per environment, per division, whatever actually makes sense in your scenario. So this helps with that isolation, which also means if one gateway goes down, not everything goes down, and you have the resiliency between all of them. It will work like any other gateway we have today. It will just be a separate ARM resource that we are introducing for this. Who would like to have this today? Okay, Jonas. Thank you, Jonas. Okay.
He said please.
Sorry?
He said please.
Okay. So let me show a couple of things before I do. Oh, it finally worked. So let's see if it's in time for the next demo. I like to burn money with Azure load testing, but that's for later. So I have here an API management instance with a very low resolution. Okay. So what I have here is I created an API management instance in North Europe, which is a premium SKU, and the platform version is STV2. If you go home and you have an API management instance that says STV1, please cancel your recon plans and migrate to STV2. Do it on Monday, that's okay, but we're actually deprecation passes end of August because we're getting rid of cloud services. So you really need to start moving, but okay, I have STV2 here. Basically, this means the gateway runs on VMSS under the covers. So let me show the creation experience because there is an interesting part there, which I skipped. And you need to rush for time. So if you create a new API management instance, there is 2 things to note. It defaults to standard V2, which now has an SLA because it is GA, and I can just pick how many units I want. But we're talking here about premium, so notice what changes. In premium, I get to choose which availability zone I want to use, and then depending on the units, I can add more. Note that you didn't see this for standard V2 though, because in in V2 SKUs, we're using availability zones by default. So if you use 1 unit, we're going to spin them in 1 zone. If you have 3 units, it's going to go to 3 zones. So you don't have to worry about it. In V1 though, you need to choose it because it was not there from the get-go. So please do so if you can. Okay, going back to this instance I have. So imagine I want to go to multiple regions. We have this location section here where basically you can add gateways in various regions. It's the same approach. The capacity, you assign a bunch of units, and then you can pick the availability zones. In this case, I didn't add availability zones, so I could just say, let's go to these 2, click apply. Actually, I can click apply and then hit save, and it's going to update everything. So if you want to go to a new region, this is the place where you want to go and scale out basically into a different region. Now, how do you know if you should go to another region if resiliency is not the reason? So this is where application insights comes in and is very handy, where you can use the availability checks to see how your APIs are doing. So for example, I've set this up here, and you can see, apart from a couple of outliners, everything is pretty fast. But once you start zooming in, you can see that the majority is below 1 second, but some of them are above 1 second. So above 1 second is still fairly okay, but you can see that this is always Brazil. I think Canada, Australia is also here. So if you have a very big customer base there, this is also a way to basically measure if it would be useful to deploy a gateway there so that they can go to the local gateway, which also means you're going into the Azure backbone faster. So we're just a proxy. We take the request and send it to the backend. If your backend is in Azure, that's also going to improve the latency there. Okay, so second thing I showed was the regional host name. So I can just probe this, for example. Note the North Europe 01 here. That is basically all you need to add along with regional. So if you, and this is the health probe you can use, that, by the way. So if you forget this name, like I do, if you do a simple NS lookup on the service name, you'll also see that it's going to be listed here. That means I can also, and I'm lazy, so let me just do this. You can also just talk to the Southeast Asia one if you want. So if you want to set up your own traffic routing, you can do that. If you want to do health monitoring on the regional gateway level, you can do that. Let me have a look at my cheat sheet here. So I showed this. Yeah, so capacity. Capacity is basically a way to measure if the gateway can keep up. And apparently what not a lot of people know is that Azure Monitor has the capability of splitting metrics. So for example, here you can see, our service is at 34%. So you can basically split and then see, okay, out of that total capacity, the majority was in North Europe, so Southeast Asia is fine. So that can also be a way to measure, okay, of all the locations we have, North Europe is like the bottleneck. There's 2 ways to fix that. One is you can consider adding another gateway in another region that's closer to distribute the load. Because at this point, if North Europe goes down, you're going to lose the majority of your traffic, right? So going to West Europe, France, maybe not West Europe, that's full, France Central, UK, whatever that works with regulation, that can help. Or we have integration with Azure Monitor Autoscale. And this is why I wanted this one to run faster, this load test. But I'll show that later on. What that basically allows you to do is ask Azure Monitor to say, when capacity goes above 70%, start scaling out. When it goes below 40, please scale in. This sounds super simple, but a lot of people don't know this is baked in, and you don't have to worry about it. Now, in this case, I did the simple approach, but same applies here. You can also do this on a regional basis. If you do not do this, I believe it's going to scale out the primary gateway by default, which is not always the good mitigation if, in my case, Southeast Asia would be overwhelmed. So you may want to set up auto-scaling on a regional basis. And then you can basically use the Azure Monitor history to also check when you were scaling out your units based on the load. OK. So another thing to think about is if you're using external caching, which I did not set up, you may also want to consider adding a cache in a region, because otherwise that's not going to work very well. And then lastly, while we do have a managed service, you can also use our self-hosted gateway, which is this guy, which basically allows you to deploy our gateway. No, don't use YAML. Deploy the gateway to Kubernetes, to Azure Container Apps, to other clouds, so that assume Azure has a total outage. I hope it will not happen, but assume you still have a gateway running on AWS, GCP, or you have workloads running there. You can use our gateway, deploy it there, expose the same configuration. Another way of resiliency, but yeah. Any questions on this part? OK, that's easy. Moving forward, so I showed the regional usage. I did not show this. So application map and application insights is also a very good integration to understand how your traffic flows, latency, error rate, etc. So here you can see the top is my Southeast Asia deployment. The bottom is my North Europe deployment. You can see how many requests goes where, and then how many go to which backend. Very important. While the gateway may be resilient, and I can have a gateway in every region of Azure, if you're still using the same backend in one region, you have a problem. Because if that backend in West Europe goes down, everything goes down anyway. So that is something to think about. I'll come back to that in a second. Now, to recap, use availability zones. SKU-v2 has them built in. SKU-v1, you need to use a premium to use availability zones. And also, you need multiple zones to get a 99.99% SLA. Otherwise, I think it is 99.95%. So if that matters for you, also check the documentation. Auto-scaling, set it up. Make sure to set a maximum replica as well. Very important. Ask me how I know. Multi-region can be important to bring gateway closer to your customers to make sure that your total instance does not go down in case of a regional outage, and you are faster in the backbone. Chaos testing, I am saving that for last. But this is also an important point to think about. Now, apps and backends. So imagine you have a backend, let's say app service, and you want to use the new shiny, let's say, containers. You're migrating to ACA, so you need to basically route your traffic to the new backend, do experiments, etc. So this used to be a very painful thing that you had to do through policies. Now we have actually a load balancer built in. So the idea is that you create a resource which we call a backend, which now has a type pool. And all it does is it basically points to two different backends in the service. So in this case, I'm very creative. I'm routing traffic to Google and Bing. And in this case, I did not specify anything, so it's going to do simple round robin. Since Build, we announced 2 new approaches, which is priority-based routing and weighted routing. So now you can also more influence what that looks like. The second thing we did was introduce a backend. Both of them are GA since Build. We've had them for half a year, I think. So that if your backend is having issues, you can open the circuit on the gateway and don't even bother sending it through because you know it's broken, it's overwhelmed, so we'll allow it some time to recover. That's the idea. You can use percentage or account-based, I believe, and we're working to add synchronization across instance. So I mentioned we have 1 unit, which is 2 machines. So if you are lucky, it's going to allow a couple of more calls because the synchronization is not there yet. Okay, so let me show this quickly. So I have this backend here because it's almost lunch, which just returns different flavors of bacon. Sorry. So I'm going to use this. It's just returning a simple list with payloads. And if I go to APIs, oops. I have a bacon API here with just 1 operation, get bacon. So if I go to Postman, I actually have this set up. So this is my very creative demo app. It gives 5 flavors of bacon. Apparently, these are a thing. Never heard about them. So there's a couple of headers here. So I added upstream URL. I added a polar bear, the region of the gateway, the name of the service, the ID of the gateway, and if it is managed or not. These are all basically baked-in information you can use in the policies. Why is this useful? I'll show that at the end. But in this case, the upstream URL is important to show. So here it goes to Wonderful Beach, which is basically one of Container App's host names. And this is because I believe this is the default, which you can see here. I don't know why Portal's so slow, but okay. That is the default. So what we'll do now is we will make this bigger because it's small. Jesus Christ. Okay. Of course, we have a co-pilot here. No, I'll save that for later. No, go away. Okay, so in the past, when you wanted to do load balancing, this is what you had to do. Okay, it's a little bit too big. So you had to be very creative and basically say, give me a random number between on 1 and 2, because I have 2 backends to load balance across. And then the default upstream URL is the one defined on the API. So then we have a choose that basically says, well, if this generated ID is 1, let's assume it's the default. If it is 2, then change the backend to this new URL to route to. And if we messed up the policy and there is another value because we updated it here but not here, then let's return a 500. And then all we do is we set we use the set backend policy, and then we fill in the host the URL of the new upstream. This is very cumbersome. You need to know how this works. So what we did was we have this pool now that I mentioned, where in my case I have 2 backends already, Contoso. Actually, the names do not match anymore, but a monolithic approach and then a new approach. And instead of sending traffic to these directly, we're going to set the backend to this new one, which is called Products Load Balancer. So now the policy just looks like this, which is a lot better. So let's take this. And now I remember, I actually need to use my other API, not the bacon one. So let's do that quickly. So this guy here still has the policy. Interesting. I didn't clean up. So it already has the policy now. So what we will do is we will basically we will first make the portal a bit bigger. And then we will send a request. And then see that it was calling the monolith on app service. And then next, monolith, container apps. The portal is not so slow today. App service. So you can see it's basically doing the round robin for us. Now, this is very simple, but what if it goes wrong? We have this capability called API Inspector. So if you click trace, and it did not ask me for if it's allowed. Interesting. Okay, if you use trace, you basically can get a trace. If the portal's, okay, here we go. You can get a trace of the request. I typically call this the request's life cycle. So if you need to debug a request, this is where you need to go, because it shows the request that was made, and then it goes through every single step. So it was able to resolve the operation that was called. It was then checking course is not used. Then it sees it needs to set the backend, which is this name of type pool. That one then forwards it to this one because it resolved it this way, changes the backend. This was the old one, this is the new one, there's no proxy. Then it shows the request to the effective backend. Then the response comes back with an OK and headers, etc., etc. So the more policies you add, this is very useful. Also, if you open a support ticket, this is going to increase the time to mitigation or resolution, because this helps a lot for us. We do not have access to this. So, and then here you can see that it added all the headers. Now, let's break stuff. This is what I prefer. What the hell?
You said let's break.
Yeah, exactly. What the hell? See, that's what I said. I'm a chaos monkey for a living. Okay, so this is where I need to bake an API. So I send a request, which is basically here, going to this container app. It will always give me the bacon. Now, imagine your backend is failing. So in this case, I just introduced some chaos. And now it starts giving me 500s all the time. So this is not very useful. I'm just clicking the button here, but imagine you're getting tens of thousands or hundreds of thousands requests. You don't want to keep overloading this backend. So this is where this circuit breaker comes in. Instead of sending it through, basically just open the circuit. And here I'm basically using a backend that says as soon as there's 5 failures in 1 minute, which means one of these status codes, then open the circuit for 1 minute. And same applies here, actually, let me copy this. If you apply this policy, which again, all it does is set the backend service to this circuit breaker. It will open the circuit after 5. And here is another example of the valuable policy expressions we have. You can get information to all the errors that a request has. So in this case, it's circuit breaker. If this would be your web app, it will also produce an error. Or in case of a policy, this is how you can use it. I'm sending it to the client. No, don't do this. Send this to your telemetry or whatever, so you have insights. But I'll basically apply this. In case somebody wonders, yes, you can combine load balancer with circuit breaker, I believe. Read the documentation. If we do not, we definitely will. But you can basically mix and match all of these. Portal's having a very bad day, so I need to talk more. Okay, let's see if this is not going well. Okay. So, okay, of course, when I stop testing, it works. So, I'm doing a few calls. Boom, call succeeded, sixth one said 503 service unavailable. This is the circuit breaker kicking in, which you can also see here in this error information that I started propagating. So this is a simple way to do it. And just to prove the point, I like Azure load testing, so I simulated a scenario here yesterday where how many did we send? 440,000 requests, and it was always calling this one where it creates the 500. So it simulates a 500, it causes a 500 on the back end. But note that we only got 1K 500s. The majority was 503s because I applied the circuit breaker. So what was happening was we get the 500s, circuit breaker opens for a minute, which creates all the 503s. We check if the health is fine by closing the circuit again. We keep on getting the 503s, so it opens it again. Now this is a load test. I could not change the request, but imagine in the middle, the backend was suddenly healthy. You would see that the circuit breaker closes again and all errors are gone because it sends it through now. But yeah, like out of the 440K requests, we were able to deflect 437K from the backend, which hopefully allowed it to come back. That's the point I wanted to make. Okay. So, what do people do if the backend is slow? Because they always read that retries are wonderful. So they use a retry policy and just retry it and retry, which basically causes downtime on your backend. Who had this before? I already saw Saka laughing, I knew. Okay, so this is a natural mistake. So that is why consider using these circuit breakers by default, because this is not where you want to be with production. So there's another fun exercise, is what I call the mystery of the capacity murder. So this is based on a live scenario I had with a large reinsurer when I was still a consultant. And we had a partner that was very enthusiastic. So this is why my load test should have started earlier, not during the talk, but let's see. So what I did here was, let me take a step back. So this is Azure load testing. Who has heard about it before? Okay, that's what I like to hear. They did a big update at build, and now you can run one load test with virtual users from multiple regions. So again, if you want to test how your gateway reacts across the world, and you have a big wallet, this is where you can go. I'm joking about the wallet. You can choose how many users you want to use, but I always exaggerate, because why not? So I started one here that has, it's simulating 4,000 virtual users, and I'm hoping to break the gateway. Shouldn't, but let's see. I'm breaking the backend, yay. Oh, actually, it's the 503, so this is the circuit breaker that I applied. Yay. So why is throughput so low? Oh, it's still ramping up, yeah. We're at 4K virtual users with machines in 2 regions, and apparently they're not displaying this. Can you split? No. Oh, here. So out of these, 3K is from West Europe, and then the other one is, oh, now it shows it. So here you can see the growth, you can see latency. You can see latency is very bad, so I guess I messed up this load test while doing it on stage. Not recommended. So the goal I wanted to have is, let me fall back. Don't change your demo right before this presentation. So I wanted to have something like this. It was not generating enough capacity, but imagine your API management instance, this capacity is going like this. Oh, it went up. Not as high as I wanted, but imagine your capacity goes up. And you are, not in this case, but at 100%. What do you do? Why are you at 100%? there's a couple of things that you can do. First of all, mitigate the issue. So mitigation is fairly simple, scale out. Make sure you get more capacity. So this is again where you should use this splitting to see which one is overwhelmed, scale that one out, etc. Second of all, make sure people cannot abuse your system. And abuse can be very simple. So in this case, I have, actually I'm not going to show it, but I have simulated a scenario where somebody is generating a ton of requests, which you will also see, or like natural reaction is capacity is high, so we must get a lot of requests, right? Hopefully, otherwise you have another problem. So here we see this sudden increase in all these requests. But why? It was fairly stable before. So how come? Same here is you can add some of these splitting, like what was the response time. Everything was fine, starting to get overwhelmed, but we still don't know. So if the load test would be running, what I would recommend is create a rate limit policy so that you prevent people from continuing to overflow. At this point, we don't know what's causing this, but let's just add an additional safety measure, either on a given API, but in this case, we don't know where it's coming from. So what you can do here is, actually, let's try this. Generate me a rate limiting policy to block requests to only allow 5 requests per minute. It's a stupid number, but just because then it becomes demoable. So let's see what it comes up with. But we have this rate limit policy that basically allows you to say X amount of requests in Y amount of time. And we also have rate limit by key, which means instead of having a global rate limit, you can define what the key is to rate limit on. Very common scenario, subscription key or API key, so that you can do it on an individual API key. I am not so patient, so I will just, oh, where did it go? Okay, I offended Copilot, sorry.
Maybe it's applied already.
No, it doesn't apply. So now it's going to, okay, interesting. Okay, let's do it ourselves. So I have here a very simple policy where we're going to rate limit, in this case, we don't have much time, nor load testing. So we're going to start blocking requests once they do 5 calls in 60 minutes based on the user's subscription ID. So, actually, let me just copy this line. So again, if the load testing would work, we would almost instantly see this in action. Oh, it cannot assist with my sorry. Okay. Interesting. What? Oh, I misapplied it. This demo is not going well. Okay. So I'm applying it. I applied it on the all API scope because we have no idea where it's coming from, who's doing it, etc. So I'm going back here. And because I applied it on the all API scope, this policy is going to kick in even before the circuit breaker. So, Jesus Christ. Let's start hitting this button. And then as soon as I do a couple of calls when it is applied, see, so we get a 429 issues mitigated, so we can start doing the investigation. Actually, I don't know if this guy is still running. No, this is the old one. Although this one was broken, we will now also see that it will start showing some 429s eventually. Oh, whatever, this is dead in the water. So now that we have mitigated it, how do we know what was going on? So there's a couple of things that we provide you. So first of all is the API analytics. So API analytics is a very powerful way to, hence the name, analyze what's going on. So you can get a timeline, response time, etc. if you care about that. Here you can also see the latency per geography. So again, multiple units, different regions. This is the information you can use. And then I will go here. So you can have the same information on API, operation, product, subscription, user request scope. I don't know what's going on. So, how's the weather today? Okay, here we go. So in this case, you can see that all the requests in this case came from a subscription called Malicious, which did 8 million requests, of which 18,000 were unauthorized. Why were they unauthorized? Interesting. I guess that's the messed up load test. And now that we have mitigated the issue, we know that this person was malicious. So a couple of things you could do. You can revoke his subscription. You can rotate the key on his subscription because maybe his API key got leaked, etc. But now you know who did it, and you can contact them. This is a true story. One person had this at a client I used to work with, and instead of polling every 1 minute, they decided to do it every second. So we said, please stop, and they didn't do it, so we made them do it. Now, this approach, hence the name, is classic. This is not the future. I don't know if it's deprecated, but we have this new approach here, which offers the same thing. And why is this interesting? It is built on top of log analytics workspaces. So basically that means we give you the data, we give you this workbook by default, but you can tweak it. So a common ask we get is how do we monetize our APIs? Well, you can use this and basically tweak it so that based on the user, you know which customer it is. You can then add your prices, etc., to those workbooks. So same information that you have here. Okay, did it kick in here? Oh yes, at least it worked here, 429. So now this test is also getting blocked. What I was not able to show, because this one did not work, is that the auto-scaling would have kicked in. So let's check, but I'm not expecting that to work. No, capacity was not high enough. Anyway, you get the idea. So you can first mitigate, check metrics, apply policies, and then investigate further what was going on. So we used load balancer to route traffic. That is not the only approach. We also have context properties for the gateway that I showed. And why is that important? If you have multiple gateways, you may want to change the backend to the regionalized gateway. So if you have one in West Europe and Southeast Asia, you want to call the Southeast Asia API when you're in Southeast Asia. So you can do deployment.region, for example. We also have the gateway ID, gateway instance name if you're using self-hosted, and also an indication if it is a managed gateway or not. Again, if you're using self-hosted, your routing will be different, so then you can use all of that. Or you can set up your own traffic manager, both before API management or after. So a traffic manager can be a backend hostname as well. So, of course, AI. Just using AI here as an example to showcase why these things are important, where typically you start with this one app, in this case an intelligent app, and you have this one backend, but then you start to become more successful and you have a lot more traffic to this one backend. So people always ask me, when do you introduce API management? I always tell them at the beginning, the very first beginning, oops. Here because changing this situation is a lot easier rather than in this situation, because you need to migrate more apps and clients and whatever. So in this case, if you have to kind of do load balancing or whatever, this is hard because you rely on a third-party service. So you don't know who's using it or whatever. So that's where a gateway always comes in, be it a Gen AI gateway with AI capabilities, but because of having the gateway in the middle, you can do all of these things for you and offload from the backend usually. So in this case, for load balancer and circuit breaker, in terms of Azure AI or any backend, you can just shift all the traffic there. Okay, to summarize apps and backends, I don't know how much time I have left, probably over, but 4 main things. Prevent abuse, so rate limit, quotas, etc. are very important. Protect your backends. Use circuit breaker to protect them on so that they can basically recover from failure. Use load balancing in case you need to, and use retries, but use them very carefully. Let me check time. Okay, I need to hurry. So unleashing your inner chaos monkey. So Netflix coined the term chaos monkey because they started shutting down VMs in production randomly to check the resiliency of the platform. Kudos to them in terms of having the balls to do that. So this has started to become more of a term. We do not integrate with Azure Chaos Studio, but that is an Azure service where you can do this basically as a platform, as a service. However, we have some capabilities that can help you. For example, using Azure load testing is a very good way to start. Throw a lot of load at it and see what happens. We get a lot of questions on how much capacity or units do I need to have X requests per second, or which regions do I need to go to? Should I go to multiple regions or just have multiple units in one region, which was literally a question yesterday. Our answer is always measure it yourself, because it is very customer specific depending on policies you have, infrastructure you have, networking you have. Now, the interesting thing is not only how will the gateway scale or react, but primarily how does your backend react. I work on the self-hosted gateway along with the managed. For self-hosted gateway, this is a very big topic. They're telling me self-hosted gateway is slow, but they forget that the backend is also part of the request cycle. So that typically also is the problem in these cases. And just to give an idea, we have automated benchmarking set up for all our gateways. And we've set up this backend, which we call Godzilla. 1 minute, okay. We have set up this backend called Godzilla, which has 1 million requests per second to make sure that we do not have the backend as a problem. So rule that out. But the fun stuff is you can simulate an outage, because you can basically shut down the gateway in every region, not every region, in all regions except for one. So there is a flag in ARM, which is called literally disable gateway. If you turn it on, we're not going to start the process. So there's nothing going to handle the request, which means all traffic will go to another region. So I have half a minute now. Instead of answering these questions, if you're using API management, think about all of these. What happens? How will you know them? Always apply rate limit by default. Be careful with health probes as well. They're very noisy. And one I will answer. If your primary region goes down, your control plane goes down, which means you cannot mitigate anything. Keep that in mind. So in case you want to shift traffic to another region, you cannot apply policies. So make sure to think about traffic management up front. And here are some links if you want to learn more. But thank you very much.